Funding for this program is provided by Annenberg CPB to advance excellent teaching.
I use a lot of writing, drawing, and then later on have the students explain what were they thinking about when they wrote something.
I like to ask kids questions. I like to ask them deep questions, why do you think that happened? I want to hear how they process.
We get to know each other, we talk about family.
I have to learn about them.
What are their responsibilities to their communities?
All the kids are really good if you just sit down and listen.
I rephrase the question. Maybe the question was wrong.
So that they have an awareness, an education, and a tolerance for other cultures.
You improvise every step of the way.
I know what a certain child's best is, and I expect that.
It makes me feel really happy to be a teacher. I'm kind of choked up.
Remember that old game of telephone? One person whispered a message to another who whispered it to another and so on until it came out an entirely different message in the end. When you talk to your students, what do they hear? What do they understand? And what can they remember and use later? The answers to these questions have a lot to do with how all of us process information. How can we teach so that our students can make sense of all the new ideas they run into each day and use them effectively later? I'm Linda Darling Hammond, and that's our challenge for this session of the Learning Classroom. When we introduce new material in the classroom, each student makes sense of it in his or her own way. One may remember a past experience and then place the new material in a similar category. Another may hear only a string of words until a hands-on experience is made available. A third may misunderstand the information to make it fit better with what he already knows. All of this is part of cognitive processing.
Cognitive processing is a more technical term for phenomena that teachers and parents around the world understand. Young kids think and reason and discuss, and what cognitive processing refers to is what is their mind doing as they do those things. And in the same way that a computer processes information, the mind processes information. And that's why the term cognitive processing came about, is efforts to use computers to create models of how humans reason and think.
There's several things that teachers can do to help students process and understand new information. We can connect new ideas to the things the students already know. We can present ideas in many different ways. For example, visually, orally, and hands-on, so that different learners can get access to the information. We can use vivid representations, pictures, analogies, charts, graphs, that make the ideas come alive. We can organize the information by identifying the big ideas and finding the categories that create order among a lot of otherwise disconnected facts. And we can make sure that students have a chance to really work with the information. Faye McLean, a first-grade teacher at Paddock Elementary School, helps her students organize what they're learning so they develop a mental map for the new information.
In my classroom, every topic starts with a question. So it's a mode of thinking. It's a habit of thinking. So that problems are really not problems, they're questions to be answered.
Gills. What are gills? Do you remember what gills are? Yes, Eric.
The things that they breathe through.
Yeah, that's kind of like they don't have a nose. So
like
they breathe through the
nose.
gills. That's kind of like their nose.
The initial activity that I did was to give them lots of pictures of animals. And my reasoning for doing that is because, well, it's another way of learning. It's second-hand knowledge. It's somebody else's first-hand knowledge that they have put either in photographs or on print. And so we'll learn from what others already have experienced. And by looking at these pictures, the children decided how to group them.
I do not like snakes. Snakes. I love snakes. I want snakes. I want snakes.
And then we looked at each group. For example, mammals. Why did you group these animals? Why are they in one group? Well, they all have hair. Then we talk about, they walk. They all have legs. The common things about animals. Their babies look like their parents. And I would ask questions to kind of draw the kinds of concepts that I want them to draw. How do they move? The birds have wings. The fish have tail. Yes, Sarah? Which one of those have feet? All right. Do they all have feet?
Turtles have.
Okay. Some have feet. The trip to the museum is embedded in the unit of animals. We go to the museum where they have Michigan animals, and they are in these cases that show habitat to some extent. So before we went there, we look at some of their characteristics. So when they go to the museum, they have some background of what things they could look for. After the children have connected their ideas or their thinking from the pictures that we looked at from the very beginning of the lesson, and some of the books they've looked at, the museum that we went to, what they saw there, and the videotape that they saw, they will construct a kind of a setting. We call it setting because we're relating it with setting for story. A habitat is a sort of setting. And continue with their pop-up book, which illustrates every kind of animal that we have looked at. Each page represents is a representative of a particular group of animals, and then the child makes a habitat or a setting for it. And so this is another one of the aids to help me assess whether or not they're understanding the concepts that we are learning. Is this the end of the sentence? Oh. Thank you. Good thinking.
Faye creates activities like the museum trip and the Habitat Project to make what her students are learning come alive for them. As they engage in these activities, they process the information more deeply and they draw more connections.
One of the best ways for students to explain their thinking is through their writing. That's where we interact with literacy in social studies and science, and really mostly anything. I use a lot of writing, drawing, and then later on have the students explain to the rest of the class why they drew some things or why they wrote that. What were they thinking about when they wrote something? Can you read it to me?
My grandma bought me a wooden reindeer at the craft show.
Oh, did you go to the craft show at school? Oh, that's neat. Who else came with you?
My brother.
I use journals as a free write for the students. They write anything they want, the silly things, the complaints, anything at all. So it is a very good tool for me to assess their thinking. In a cognitive sense, that clears their mind about their thinking and writing. It's connecting together. They write it down, they read it. If it doesn't make sense, they write it over. Or they think first and then clarify their thinking so that they can put it on paper. So it is a tool in that sense.
Today PBS came. It's weird, but it is worth it. And it is cool. We are getting better at writing. It is fun.
With the younger children, because they don't have any experiences with organizers, we call them graphic organizers, I look at their thinking first and organize them myself, and they will see how they're organized. It's later on when they're doing their own kinds of organizing or their own thinking of their own writing ideas that they do borrow somehow from previous organizers that have been used in the classroom as a class.
Hey, these were some of the things you listed out there that we needed. Okay, let's start reading it, please.
Telephone, soap, stove, car, refrigerator.
For example, we recalled the needs of the family. And then I posed the question, well, what problems could arise with these needs of your family? So then there's a problem. And we brainstorm on, you know, for example, if a car breaks down, then you need a repair person or something like that. And then I ask them to think together about problems that they might have had at home.
How do we know when the shower is not working? Yes, Ashley.
The water doesn't run.
The water doesn't run. Okay. No. Can we just say no water?
No water.
Quicker to write? Okay. How about lamp? How do you know something's wrong with your lamp? Eric.
It won't turn on. The light bulb's burnt.
So in my writing down on chart, I listed down the needs, and I asked the question, I put the problem right next to each one. And later on, I drew the lines to separate them and in essence group them in different ways. Another way that they can explain their thinking is to work in projects in tandem with another student or other students, if it is a community helper, because maybe they have a common experience with that community helper, like a mechanic or something like that. They both have common experience of having their cars break down and their parents had to call a mechanic. So that is another way of explaining their thinking.
I was 100 miles from home when my car broke down. I was.
One day I was all the way in Ohio and my car broke down. Dad called.
I was at my house.
You're lucky.
You're lucky. We had to call a tow truck to tow it to PAT.
In our lesson today, I will not explain, but extend family needs to the whole community, that we really do need other helpers that may not be directly helping your home or your family, but are helping in the general community so that they do affect each individual family.
They picked out fire.
No, they put out fire.
Yeah, that's a good idea. POT.
We come from just the immediate need to bigger needs, and there's where the bigger concepts later on come from. And hopefully they can continue to do that as they go into higher and higher grades.
Faye McLean gives her students many ways to learn new material so that everyone can find a connection that works for him or her. She helps them develop categories to organize their thinking, and she helps them reason through the new concepts. By having them talk and write and draw about their ideas, Faye encourages her students to visualize as well as articulate their thinking.
Visualizations provide a new window into thinking beyond hearing students talk. So a student who might be less verbally oriented may be quite willing to draw a picture of how they're thinking about things and to even label its parts in a way that can then become what we would call a conversational prop for a learning conversation, something that can be pointed at, refined, talked about in a learning community in which all of the kids in the classroom are creating visualizations. And part of what's really interesting when a teacher does this is that you find real differences in the diagrams and the pictures that kids create.
Sandy Gilliam is a 10th grade math teacher from San Lorenzo Valley High School who introduces new concepts to her students by building on their prior knowledge of history as well as mathematics. She checks for misconceptions by getting them to talk about what they think. She also uses many ways to represent ideas so they connect for different learners. Finally, she gets them actively engaged in making sense of the new concepts by working through an authentic problem together.
I think the kids need to have a hook of someplace they've been before. What I try to do is connect it to something they've had before, an experience they've had before, or a historical moment from another class, or a science experiment, or say an Edgar Allan Poe story. And then I try to get them in the mood of that, kind of get their mind in thinking about that, and then add little pieces that I can hook to pre-existing knowledge. To the observer with a discerning eye, significant changes had come about in the immigrant parties that assembled along the Missouri River towns of 1852 and 1853. By putting this lesson in the context of the Oregon Trail, they get this visual image in their mind. And so we've got the historical context, and then I've added in variables. These kids have never been exposed to algebraic variables before, and in a way that they understand the variable.
25 men in a wagon train.
25 men in a wagon train. So that makes sense to everybody, right? And by putting the variables in the context of the Overland Trail, they have really understood and made their own equations strictly with variables. And it just really builds up their knowledge base. And so now we've started graphing. So again, we're connecting to the Overland Trail story that I read, and we're connecting to the variable that they used. So it's reinforcing that concept of variable, and now we're translating it to a graph to see pictorially what would that look like. When we're doing the graphing on the Overland Trail that we're starting to do, you're going to have to make sense of what the graph is showing you. And you're going to have to think about these things, what time of day it is, what's the weather like, how many people are on the trip. All of that is going to have to come into your mind, into play, in looking at graphing.
Our math program here uses, just by virtue of what it is, we use a number of visual aids to start with. So a kid who has an auditory problem, processing problem, where they're not necessarily hearing what Sandy's saying to introduce a unit or what I'm saying, what we have for them as we go into a unit are diagrams. For instance, just one of the things that I think has been really helpful, the kids had to create a list of what they wanted to take on the Overland Journey Trail. And we started out with a sheet that just had all these different supply items. So even if a kid never heard anything we explained, we had that sheet that was simple and to the point where they could see what needed to go, and they had to actually do something with them besides manipulating numbers. The important thing, you guys, almost everything we do in math here, we'll start out with words and on the board in the big group, and then we bring it down to more individual ways of teaching everybody and with many visual aids.
Does that make sense now? Could you put the next point there for me so I know you know it? Rather than just start at the beginning of what graphing is, I wanted to see what kind of background they all brought to the graphing. And so I noticed what was happening, and that's very interesting for me as a teacher to see where the holes are, what the memories are, what the kids are perceiving with graphing.
These beliefs that they have are important to understand for us to go building on in instruction. So prior conceptions, some call them misconceptions, we prefer to call them prior conceptions, are one very significant influence that work in the learning sciences has helped reveal over the last number of years, and that I think teaching can really pay attention to.
So let's look at what a graph of this would look like. Okay, who thinks they could come? They know enough about graphing from back in junior high that they could come and actually make a graph of this. Okay, Brett?
Weather clear and pleasant. Distance traveled. Anybody?
Stop. Would you stop and explain so I can see what you're doing? What do those mean?
Well, there's no 1 and 2, but there's 2 families with 4 men, and there's 5 families with 10 men.
Okay. Does a graph normally have those boxes on it? When Brett came to the board to do his graph for that equation, y is equal to 2x, I noticed he was putting those boxes and was trying to figure out if that was some method. I mean, he wasn't plotting points, he was making boxes. And I was afraid of the rest of the class thinking that boxes was a part of what we needed to do, and then had to switch in my mind and get the kids to realize that I was really just looking at the points that represented the data from the in and out table. What should I see when I'm looking at a graph instead of boxes?
Marks.
What was that? Dots. Okay, and where would the dots be located, Jamie? The points.
Yeah.
Could you take the corner at each of those boxes?
How about using
Thank you, Brett. I like to ask kids questions. I don't like to ask them a whole lot of one-answer questions, like how many sides are in a triangle? 3. I like to ask them deep questions. You know, what do you notice about those points on the line? Why do you think that happens? I want to hear how they process. Okay, so we don't have a line. Do we have a ray?
Yeah. Yeah, maybe.
I want you to think about, do we have a ray in this situation?
Well, right now,
we connected those points with a line. That's what Brett did. And you extended the line up to this point, and they're all on the line. All these X's are on the line.
There isn't a point at the 0. It's like there's a line, but there's no point at the end.
Should there be a point at the end?
No.
There can't.
Because there's no 0.
Well, she says there's no 0 over here on the chart. There can be. Why can't there be?
because there needs to be a starting point.
The starting point is 2.
But you can start at 0.
You can have 0 men and 0 families.
I can have 0 men and 0 families. Does that make sense?
Yeah.
I try to get my kids up to the board and ask those questions. They have to go up and they have to explain what they're doing.
Okay, you start out on the trip with like a full stock of coffee.
Well, what do you suppose a full stock of coffee might be?
Just like 500, I don't know.
Fine, 500 pounds of coffee. Why don't you put 500 up there? And then they have to answer questions from their peers, and then they have to answer the questions from me that are related to what they did, but they have to thoroughly understand what they're doing. What it does is the other students in the classroom learn to, because they want to protect or help the person at the board, they have to pay attention so much more.
Is that wrong?
Yeah. Keep going. Who has this? What you can do is turn to them and ask for a suggestion.
Suggestion? Right.
Like days there? First day, second day, third day, fourth day.
The person at the board's got to think. The students who are sitting back have to think, because they know those questions aren't going away, and I'm not answering the questions. Now can you explain the graph?
Day 1, they start out with 500 pounds of coffee. Day 2, they drink some of it and they have 375 pounds.
And especially with a class where you have low self-esteem or you have special needs students, there has to be a lot of different ways of interpreting the information, whether it's visual or kinesthetic. You know, they have to find a way that deep thinking happens. You know what? I love these questions because, again, we have to, well, we don't know how many people are on the trip, but we have to figure out what you know and what you don't know. Many times people just plot graphs, and kids don't understand the concept or the meaning, what's happening in the graph. So if we take away the data and we just use a scaling like over time, can the kids interpret graphs, and can they understand what's happening when graphs have dips or when graphs have straight lines? Can they look at that and think about it rather than just plotting individual points on graphs and it just becomes an exercise in can you plot points? I want it to be looking at data and understanding data. Kyle said they didn't take any water here or they didn't drink any water here. Why? Say that again?
Like when they started out with lots of water and then they drank a lot. They dropped.
And how do you know they drank a lot?
Because it went down.
Say it again. Use the word drop. That was the word I was looking.
It dropped down.
Which means they
drank a lot of water.
A lot of water. Did they drink a little water?
No. Then when it flatlined, they were very conservative until they got to the stoppage point to restock. Then it went up.
And why would it go? Why would it go?
Because they got all their water back, and then they went down again, and they flatlined. Then it's gonna probably be stocking up again.
Okay. Does that make sense?
Yeah.
Okay. Can someone tell me at which spot did they drink faster? at this spot or at this spot.
And they need to know that they're learners, and they need to know that they can translate what they learn in math class to history class, especially with the Overland Trail, or that they can translate what they're doing here, a thought process, to their English class when they're brainstorming ideas for their English paper.
We wanted to create a class that met the needs of all kinds of learners, that all kinds of intelligences. So we have interpersonal and intrapersonal, and we have kinesthetic learners, and we have musical learners, and we have visual learners, and all of Gardner's different intelligences, and we try to make sure that however kids learn and process, that the class holds something for them.
Part of what this teacher does that's extremely useful is setting the problem-solving context in a motivational one of human narrative and drama. And that helps attract students' attention, probably relates to situations they could imagine themselves in, as opposed to being simple, dry, decontextualized formula. She then gives them the opportunity for reasoning quantitatively about their use of supplies during their trip, water in particular. And so they then have the opportunity to talk about what the shape of a graph would look like for water availability at different times in the trip.
Faye McLean and Sandy Gilliam take time to attend to their students' thoughts as well as their actions. They help students organize their thinking, and they encourage them to present their learning so the class can see many ways to think about a new concept.
People that have studied even elementary school children's understanding of memory, of language, of reasoning, they're quite reflective about these things. They recognize that when they're tired or distracted, they don't do as well, they don't remember as much. So they're attentive to cognitive processing. What teachers can help bring to the equation from the learning sciences is much more attention to teasing out what their learners are thinking and believing by having them represent that knowledge in conversations, in pictures, and in other modalities.
The many different ways human beings think and learn is part of what makes us who we are. When we adapt our teaching to help all kinds of thinkers acquire and understand and apply new ideas, we help them create meaning both for the classroom and for life. This is the Learning Classroom. Thanks for watching.
Funding for this program is provided by Annenberg CPB to advance excellent teaching.